This video will review Section 7A on Fundamentals of Probability. Now, the notes that you see here is all on your Week 9 lecture notes. If you were absent, you can find the lecture notes in Blackboard under the Content menu in the Lecture Notes folder. Now, let's go over some of these definitions here. So, an outcome is basically a possible combination. An event is an outcome of interest, and events are often expressed by using capital letters. Now, P of A is the abbreviation for the probability that an event A will occur. And the formula for that is basically number of possible outcomes for the event of interest over total outcome. And your probability is always between 0 and 1. So if you got an answer greater than 1, then you probably did something wrong with your math calculations. A probability of 0 basically means that the event is impossible to happen. So for example, what is the probability of you going to a grocery store and finding a rainbow-colored banana? Basically 0. Probability of 1 means that the event is 100% certain to happen. So what is the probability of you going to the grocery store and finding a yellow-colored banana? 100% or 1. Now again, technically probability is often expressed as a decimal, a fraction, or a percent. So you have to remember 1 is basically 100%. And sometimes I will switch back and forth between the two, depending if it's a fraction or decimal or it's a percent. Now on the right hand side, we have an example. So the example here of flipping 2 coins. So what I did was create a probability distribution, which is a table consisting of all possible outcomes or combinations. So here we have the first coin for the first column, second coin for the second column. So one possible combination is that the first coin flips tail and the second coin also comes up tail. So tails and tails. Or another possible combination is heads and heads, or tails heads, or heads tails. So let's say A is an event of getting heads. So we're only interested in getting heads. So that means we're only interested in anything that has heads in it. So we have one combination with 2 heads, one combination with 1 heads, and one combination with another head. So if they ask you, what is the probability of getting heads? So P of A will be 3 because we have 1, 2, 3 combinations with heads out of the 4, which is your total outcome. Okay, so that basically applies to this formula here. Number of possible outcomes over total outcomes. Now, P naught of A is the probability that event A will not occur. And here's the formulas, a couple formulas for P naught of A. So P naught of A is basically 1 minus P of A, or if it's in percent, 100% minus P of A. Now, I often refer P naught of A as leftovers because technically it's the leftover of P of A. So if we take a look at example 1 here, it says find P naught of A. So here I basically did a kind of a visual here. So if P of A is 1/4, so it's the shaded region here out of these 4 pieces, then your P naught of A is basically the leftover 3 pieces. So your P naught of A will be 3/4. An example here, let's say P of A is 40%, then P naught of A is the leftover out of 100, which is 60%. Odds for and odds against. So odds for is basically the P of A divided by P naught of A. So you need both probabilities in order to calculate odds for. Odds against is just the reverse of odds for. So basically once you figure out odds for, you just reverse your ratio to get the odds against. And then the multiplication principle is used to calculate the total outcome. And what you basically do is you multiply all choices for each item. So for example, here on the right hand side, we have an example, find total outcome, and we have a 4-child family here. So we want to find the total outcome. In other words, total outcome is the total combinations that we can have with a 4-child family. So we know that for each child, there are 2 choices, a boy or girl. So the first child's 2 choices, second child you have 2 choices, third child you have 2 choices, fourth child you have 2 choices. So we are going to apply the multiplication principle by multiplying all the choices for each child. So 2 times 2 times 2 times 2, 4 times, or 2 to the 4th power, because technically it's repeating itself in multiplication. So that's basically 16. So you have a possible of 16 different combinations in a 4-child family. Now, in section 7a, or technically in the whole chapter 7, here's a few things that you need to know. Again, child, you have 2 choices, which is a boy or girl. A coin, you have 2 sides, which is heads or tails. A fair die. A fair die is basically a 6-sided die. And basically, you have the numbers 1, 2, 3, 4, 5, and 6. Now, a standard deck of cards, we have 52 cards total. There are 4 suits in a deck of cards. The hearts, diamonds, spades, and clubs. The 2 red suits are the hearts and diamonds. The 2 black suits are the spades and clubs. And for each suit, there are 13 cards in each suit. For each number in the deck of cards, there are 4 cards for each number. And the face cards are basically your kings, queens, and jacks, totaling up to 12 cards totals for your face cards. Alright, let's take a look at your section 7a homework guide. Okay, so here in number 1, it says, a pizza house offers 4 different salads, 3 different kinds of pizza, and 6 different kinds of desserts. How many different 3-course meals can be ordered? So in other words, they want total outcome. How many different ways? How many different combinations? So our total outcome, we're going to apply the multiplication principle rules. We're going to take all the choices for each item and multiply them together. So I often abbreviate total outcome as TO. So 4 times 3 times 6 is equal to, so here we have 4 times 3 times 6, 72. So your total outcome is 72. You have 72 possible combinations that you can get. Number 2 here says, determine the probability of selecting a 2-child family, 1 probability, with 2 girls, assuming boys and girls are equally likely. So first of all, let me again go back to the formula for probability. So probability, again, is the number of possible outcomes over total outcome. The easiest way is to actually figure out your total outcome first, and then figure out the different combinations of the events that they want. And again, for your total outcome, basically you want to use the multiplication principle. So here, so your first child, you have, again, 2 choices, boy or girl. Second child, you also have 2 choices. So for your total outcome, it's going to be 2 times 2, which would give us a total of 4 possible combinations. Now, we are only interested in the event of having 2 girls. So let's say A is the event of having 2 girls. So the possible combinations of having 2 girls is if your first child is a girl, second child is also a girl. So girl, girl. So that means that's only one possible combination. There's no other combinations that will give you 2 girls and a 2-child family. So then if we take this and put into the probability formula, so then our probability of having 2 girls will be 1, which is the number of outcomes, over our total outcome of 4. So your probability will be 1/4. And again, make sure to simplify your fraction if you need to. In this case, 1/4 is already simplified, so I don't need to reduce it. So here our answer is 1/4. Let's do number 3. So number 3 is similar to number 2. So it says determine the probability of having 2 girls and 3 boys in a 5-child family. So here, again, your first child, you have 2 choices. Second child, 2 choices. Third child, you also have 2 choices. Fourth child, 2 choices. And fifth child, 2 choices. So then we're going to take these choices and multiply them together. So 2 times 2 times 2 times 2 times 2, or 2 to the 5th power. That will give us our total outcome. So 2 to the 5th power, 32. So we have a total of 32 possible combinations. However, all we want is the event of having 2 girls and 3 boys. So we need to list all the possible combinations. Now, there's no easy way of doing this. You have to sit down and list the possible combinations. So in this case here, we have girl, 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 then boy, 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 or boy, girl, girl, boy, boy, or boy, boy, girl, girl, boy, or boy, 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 girl, girl. Another one is girl, boy, 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 girl, or girl, boy, girl, boy, boy, girl, boy, boy, girl, boy, boy, girl, boy, girl, boy, 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 girl, boy, girl, and last but not least, boy, girl, boy, boy, girl. So we have a total of 10 different combinations that consist of only 2 girls and 3 boys. So then if we take this and put it into the probability formula, P of A, it will be 10 out of 32. Now we can actually reduce this. In this case here, 5 can go into 10 but cannot go into 32, so you can't use 5. 2 can go into 10 and it can also go into 32. So in this case here, we can use 2. So 10 divided by 2 will be 5, and 32 divided by 2 is 16. So we'll reduce this down to 5/16. The answer here is 5/16. Number 4 here says the local weather forecast has been accurate for 18 out of the past 30 days. Based on this fact, what is the relative frequency probability that the forecast tomorrow is accurate? Now, whenever you see the keyword relative frequency, basically they want your answer as a decimal. And so you want to divide to get your answer. So here, because I'm using the slash to represent fraction, I'll type out the word divide to not to get the two confused with each other. So in this case here, we're going to take 18 divided by 30 to get our relative probability. So 18 divided by 30 will give us 0.6, and that is our answer. Now, number 5 is similar to number 4, so I'm going to skip that. And let's take a look at number 6. So number 6 says determine the probability given the opposite event. So basically what they want us to solve for is P naught of A. Okay, so I'll put a question mark. That way you know that we're trying to solve for P naught of A. So they say determine what is the probability of rolling a fair die when and not getting an outcome less than 3. So a fair die and not getting an outcome less than 3. So if you remember from earlier, a fair die has 6 sides and it consists of the numbers 1, 2, 3, 4, 5, and 6. So that means we have a total outcome of 6. So our total outcome of 6. Now, what we want is numbers that's not less than 3. So numbers not less than 3. In this case here, the numbers that's not less than 3 are these 4 here. 3 is not less than 3 because 3 is equal to 3. And then you have 4, 5, and 6. So there are 4 numbers that are not less than 3. So 4. So then our probability, P naught of A, will be 4, 6. And again, we need to reduce this. So in this case here, 2 can actually go into both of the numbers. So 4 divided by 2 is 2. 6 divided by 2 is 3. So our answer here is 2/3. Okay, let's take a look at number 7. So number 7 here says determine the probability given the opposite event. So it's another example of P naught of A, solving for P naught of A. So again, we're solving for P naught of A. In this case here, they say, what is the probability that a 51% free throw shooter will miss their next free throw? So in other words, we're going to look for the leftover out of 100. So leftover out of 100 will be 49%. In case of those who want to see the math, basically, it's 100% minus 51%. That will give me 49%. Now, they actually want your answer as a decimal, so move your decimal 2 places to the left. It'll be 0.49. Number 8 here says, find the odds for and the odds against the event of rolling a fair die So we're rolling a fair die and getting the following numbers here, 4, 5, 1, and 6. So in this case here, first of all, let's go back and review what the formulas are for odds for and odds against. So odds for is basically your P of A divided by your P naught of A. And then your odds against is the reverse of the odds for. So we actually need to figure out both P of A, P naught of A, and then divide. So here, since we are rolling a fair die, remember a fair die is a 6-sided die. So your total outcome is 6. And the event A is getting these 4 numbers. So our event A will be 4 because these are the 4 numbers that we want. Technically, it doesn't matter what these numbers are. It's just the count that matters. So then here, our P of A will be 4 out of 6 because we want 4 numbers out of the 6 on the fair die. Then your P naught of A is the leftover, which is 2 out of 6. And basically, now what we're going to do is we're going to divide the two fractions here. So if you guys remember dividing fractions, basically, you take the 4/6 divided by the 2/6 into your calculator, and then it will automatically give you your answer. But if you don't have a scientific calculator, you're going to have to manually do this. So let's see here. So again, what's our equation? We have So we have 4/6 divided by 2/6. And if you remember, when we are dividing fractions, you flip the second one and change the sign to multiplication. So it becomes 4/6 times 6/2. So here, the 2 6's, they actually cross-canceled out. So then you'll end up with just 4/2, which reduces down to 2. Now remember, whole numbers are technically over 1, and because we are working with ratios, you need to have a denominator. So here we'll just put 2/1. So then our ratio will be 2 to 1. So our answer for odds 4 is 2 to 1. The odds against is the reverse of odds 4, which is 1 to 2. Now, number 9, we're doing the same thing again, but with a different scenario. So they say we are flipping 2 fair coins and getting 0 heads. Now, I already created a similar example already, so let's go ahead and take a look at that. So, for total outcome for 2 fair coins, total outcome for 2 fair coins, we have 1, 2, 3, 4 total outcomes, or 2 times 2 since you have 2 choices for each coin. Getting heads, so we need to figure out what combinations will give me 0 heads. That is the event that we are interested in. So the event that gives me, the outcome that gives me 0 heads will be the first one here, tails and tails. So here has 0 heads. And that's the only one that has 0 heads. So 1. So then your P of A is 1/4. And your P naught of A is the leftover 3/4. So again, we're going to go ahead and divide those two fractions. So let me go ahead and divide those two fractions here. So here we have 1/4 divided by 3/4. So again, we flip and multiply. So 1/4 times 4/3. So these 2 4s, they cancel out, and you're left with just 1/3. So the ratio will be 1 to 3. So the odds for is 1 to 3. The odds against is the reverse. So 3 to 1. Number 10 here says, suppose an urn contains 4 green marbles, 6 white marbles, and 10 yellow marbles. If one marble is selected, determine the probability that it's green. So here, what we need to do is actually figure out total marbles. So total marbles is basically 4 plus 6 plus 10, which is equal to 20 marbles. Now, in this case here, we are not using the multiplication principle. So we are not multiplying. The reason why we are not multiplying is because we are not looking for combinations. We are just counting the marbles. So we don't need to use the multiplication principle. In this case here, we have a total of 20 marbles, and the number of green marbles is 4. So our probability of getting a green marble, it will be 4 out of 20. And again, we need to reduce the fraction. In this case here, 4 can divide into top and bottom. So 4 divided by 4 is 1, and 20 divided by 4 is 5. So our reduced fraction is 1/5. You have a probability of 1/5. Now, number 11 is similar to number 1, which is basically figure out total outcome using the multiplication principle. So I'm going to skip that. Number 12. So number 12 here says, the following table gives the gender and political affiliation of 100 randomly selected voters at a voting site. So this 100 randomly selected voters, that is your total outcome. So total outcome is equal to 100. So part A here says, what is the probability that you select a woman? So in other words, what we're going to do is we're going to add up all the women and then put it over 100. So here, the number of women, we have 28 plus 20 plus 7. So let's see what that is. 28 plus 20 plus 7 gives us 55. So we have 55 out of 100 for your probability. Now, 55 about 100, you can actually reduce that. So 5 can go into top and 5 can go into the bottom. So 55 divided by 5 is 11. 100 divided by 5 is 20. So our probability is basically 1120. Now, Democrats. Part B says, what is the probability that you select a Democrat? So we're going to do exactly the same thing, total up all the Democrats here to get your probability. Sorry, PW, since we're solving for probability. So here, we're solving for probability Democrats. So again, we're going to total up all the Democrats. We have 20 women Democrats, 12 men. So 20 plus 12, that's basically 32 out of 100. So in this case here, 4 can go into each number. So 32 divided by 4 is 8. 100 divided by 4 is 25. So our reduced fraction is 825. Part C here says, what is the probability that you do not select an independent? So in this case here, there's 2 ways of doing this. You can add up everybody else who is not an independent, or you can add up the independent and subtract it from 100, your total outcome, and then you will still get the same answer. So in this case here, we want probability of not independent. So I'll just do 100 minus 7 minus 8 here. So that will give us 85 over 100. So then 85 over 100 can be reduced further. In this case here, 5 can go into each number. So 85 divided by 5 will be 17. and 100 divided by 5 will be 20. So your answer here is 17 out of 20 for your probability. Part D here says, what is the probability that you select a male Republican? So probability of male Republican. So here we have 25 men Republicans. So basically be 25 out of 100, which reduces down to 1/4 because 25 can divide into each number evenly. So 1/4. Part E here says, what is the probability that you select someone who is not a female Republican? So in this case here, we have 28 women Republicans. So probability of not women Republican will be 100 minus 28. So 100 minus 28. 72. So 72 out of 100. And again, this can be reduced further. In this case here, 4 can actually divide into each number evenly. 72 divided by 4 would give me 18. And 100 divided by 4 would be 25. So your reduced fraction would be 1825. Now, number 13 here says, an experiment consists of drawing one card from a standard 52 card deck. What is the probability of drawing a 10? So, your 52 card deck, that is your total outcome here. So, our total outcome is 54. And we are interested in the event of drawing a 10. So, remember, there are 4 cards for each number. So then our probability, P of A, will be 4 out of 52. And if we reduce this, 4 can actually go into each number. It'll be 1 over 13. Now, number 14 deals with odds for and odds against again. In this case here, it says randomly drawing a 2 from a standard deck of cards. So again, we have 4 2s in a deck of cards. So your event is 4, and then your total outcome is 52 in a standard deck of cards. So basically, the answer will be similar for P of A and number 13. So your P of A is 4 out of 52, which reduces down to 1 over 13. And then again, because we're solving for odds 4, we also need P naught of A, which is the leftover. So we'll just take the leftover of the reduced fraction. So the leftover out of 13 will be 12/13. And again, we need to divide our 2 fractions here. So it's 1/13 divided by 12/13. And again, we flip and multiply. So 1/13 times 13 over 12. So the 13s, they cancel out. And you're left with 1/12. And ratio form be 1 to 12. So then our odds 4 will be 1 to 12. And the odds against will be the reverse, which is 12 to 1. Number 15 is similar to number 1 and number 11, basically figuring out total outcome by multiplying all your choices together. So I'll skip this one here.